equals
equals 2 over x minus 3. Find the limit f of x
as
to
x
3.
approaches.
Yeah, 3.
Okay.
And limit
From the
e
left,
of x
from the left, from the right,
from the left.
from the left. Very good.
Hold on, no, it's not from the left. There's nothing behind it.
Okay, okay. No problem. And
Limit e of x to the 4.
as x approaches 4. So the limit of f of x as x approaches 4. That's it. Yes?
Yeah.
Perfect. So let's start with the easy one, which is this. Limit as x approaches 4 from either side of 2 over x minus 3. So we had that rule that stated that if this number is in the domain of this function, all I have to do is plug it in. That's all I need to do. Since 4 is in the domain of this function, 4 minus 3 is 1, 2 over 1 is 2. I'm done. As long as the value is in the domain of the function. It is. Here there is a different situation. So when I determine the initial, or I create or find the initial assessment, so this is limit as x approaches 3 from 2 over x minus 3, I have 2 over 0. But 2 over 0 has 3 possibilities, either negative infinity or DNE. I cannot make a conclusion. I only know that the limit will not exist. But I don't know if it's this, I don't know if it's this, and I don't know if it's this. For that reason, because this is the limit from either side, I am forced to determine both limits. I am forced at this point to determine the limit from the left and then the limit from the right, and then draw a conclusion. So let's do just that. So limit as x approaches 3 from the left of 2 over x minus 3, and then limit as x approaches 3 from the right from 2 over x minus 3. Both situations are still 2 over 0. But now, so to speak, I want to determine the sign of 0. You can say, what are you talking about? Well, I need to know if this is, so if the function is coming from the left of 0, or if the function is coming from the right of 0. Because if it's coming from the right of 0, positive over positive will be infinity. If it's coming from the left of 0, positive over negative will be negative infinity. So, the same thing here. 3 from the left. If this is 3, 3 from the left is with numbers smaller than 3, like 2.9. Well, 2.9 minus 3 is negative. So then I know the answer is negative infinity here. Numbers from the right of 3, like 3.1. But 3.1 minus 3 is positive. So then this is positive infinity. And now I finally know the answer. Since these are not the same, the answer here is only this. The only possibility. So the limit from the left is negative infinity. The limit from the right is positive infinity. Therefore, the limit from either side is DNE. It's not this. It's not this. Is it clear now? And this happens when I'm asked to find the limit from either side and I have an indefinite situation. An indeterminate, yes, it's undefined situation, 2 over 0. Very good question. Is this clear?
Yeah.
Perfect. Yes.
Then can you also take the time over on limits to kind of explain again, like on the graph, when you kind of block things off to show how to find the point in the direction, but I'm still confused
You mean here?
with that. When it was on a graph, you did it on one of the classes, like one of the notes. You drew a graph and then you kind of took like your erasers and you blocked it off. Are we gonna have to be able to do that to find the limit on like the test, or are we just gonna be finding the limit based off of the equation?
So you can be asked to find the limit based on a graph that you like a piecewise defined function. You may be asked to find the limit like you just gave me this, an expression. I don't remember what I was explaining because I'm using my props here all the time.
I might have to like kind of take the note that you did and crop it and send it to you, and maybe I can use it for you to further explain it because I still was a little confused.
But do you remember the problem? Do you remember the problem?
It wasn't an exact problem. We were kind of explaining the concept.
Oh, this one here?
You were explaining limits and the concept and how you find the limits based off of just looking at the graph. But I'll just find it and I'll message it to you, and then you can kind of further explain it.
Okay, yeah, I don't remember exactly what you're referring to.
To add on to that,
Yes.
Letitia, are you talking about when there was like points on the graph and we were saying like is it continuous at like f of 2? It was like really early. I think it was probably like the first or second or maybe even third class.
No, not that graph. You're talking about the one where it has like a bunch of points on there. It says F1, F2, F3, and you have to tell if it's continuous, discontinuous. Not that. It was just a basic concept and explaining it. Like I said, I can go find it on the notes and then I'll send it to you, and you might be able to explain it. Hopefully, I might be able to find it for the class is over.
I can go back to modules quickly. Do you think that it was in the first? Do you think it was in the first class? No, not in the first class. So I have.
Are you at some point showed us like a printed out graph you had, and it was when you were first introducing limitations?
Limits, okay. So probably not August 26th and 28th, but maybe September the 2nd, no. September the 4th.
So it was when you started chapter one. It was the 1.1 and 1.2. You were introducing the limits and you were showing how they approached, and it was a graph, page 113.
Is this the graph?
41. Yes.
Okay.
So you kind of explain that again, how you determined that from the graph.
How will I determine the limits from the graph?
Yeah, because you were like using, I guess, blocking things off to kind of have a visualization, but when you were explaining it on the video, I just couldn't, I don't know, I couldn't piece it together as you were
Okay, so
explaining
this
it.
is the graph.
Yes.
Okay, perfect. So I'm asked to find the limit from h of x as x approaches -3 from both sides. So -3 from both sides, the tendency of the function is 0. That's how we got 0. Is that okay? Is that okay?
See what I'm, so with the -3 be the blacked out point, because that's what I'm confused. Am I supposed to go to x for -3? I'm confused on the concept of where I'm supposed to be looking to find this point. That's where I'm confused.
Okay. So it says here, x approaches -3 from both sides, from either side. So x is going this way. So every time I start using this feature, my PDF file freezes for a second. I don't know why. Okay, so x approaches -3 from either side. As x gets closer and closer to -3 from this side and -3 from this side, the function values get closer and closer to 0. Is this better?
Okay, now I think I get it. So I'm basically following the X.
The tendency of the function as x gets closer and closer to -3, the tendency of the function is 0.
Okay, I think I get it now.
So
Better.
now let's say for -2 from the right, here's -2. So as x approaches -2, oh, I said from the right and I'm showing it from the left. As x approaches -2 from the right, the function value or the tendency of the function is 1. Is this okay?
Yeah.
As let's do just one more. So as x approaches 3 from either side, what is the tendency of the function?
1.
Exactly.
Okay, now I get it. I think it was just the way you were blocking off when you were using the thing. It was kind of big, so I was kind of getting lost in being able to see the graph. So now I definitely understand it way better.
Excellent. Perfect. Good. I'm glad we found it. Good. We're back. Good. Back to other topics. Anything else? So the average rate of change, we should not have any difficulties. This is the slope of the secant line. So is this okay? We had an example with continuity and differentiability. We looked at this function and we wrote it. We determined whether it was continuous and if it was differentiable. This is the equilibrium point for demand and supply. This is domain. If we need examples with domain. Do we need examples with the average cost, revenue, and profit? And higher order derivatives?
I actually kind of had a question about that.
Yes.
So, is the average cost, revenue, and profit like the same as the investment part?
No. Very, very good. The investment is with when we're given a principal and an interest rate, and we're asked what is the accumulated amount after 10 years, compounded 4 times a year or 12 times a year or something like that. No, these are totally new functions. C of x over x, this is the average cost function. This is the revenue divided by x, which is the average revenue function. We discussed them last time. And this is the profit divided by x. So these are total. As you see, there is a lot of information here. The average rate of change is one thing. The average cost, average revenue, average profit are totally different. The rate of change is the derivative function. They're different concepts. Yes.
Can we go over average cost revenue and profit again? I know we did it like a couple classes ago.
Yes. So let's choose a function. They are in 1.6. We had an example last time, and we had one on the homework. Do you want me to do go back to any particular problem, or do you want me to choose one, or
Can you choose one?
yes? So I'm looking. Do you want me to show the problem that it's on this homework?
Yes.
So I think it was 60. Did I assign 60? Am I correct?
I know that was the one in the homework. I kind of forgot which one it was. The number 60.
Okay, never mind. So let's work on it then. I don't remember exactly. As I said, I did not write solutions yet. So we are given these functions. We are given the cost and the revenue, and they're asking us to find the rate at which the average profit per unit is changing. So they want us to find this when x equals 20. But I can determine the average rate of change, or the rate of the average rate of change when x is 20 before I determine this function first, and then I differentiate it. So first of all, the profit equals revenue minus cost. So 75 times x to 0.8 minus 900 minus 18 times x to 0.7. Is this clear so far? Is this step okay?
Yes.
Perfect. Now I have to create this function. So in order to create this function, I have p of x over x equals 75 x. This quantity has to be divided by x. So I have x to 0.8 minus 1, which is negative 0.2. Minus, now I divide this quantity by x. So I have 900 times x to negative 1. Finally, minus, now I divide this quantity by x. So I have 18 times x to 0.7 minus 1, which is negative 0.3. So I determine this function. Now I determine this function. Now I have to differentiate it. When I'm done, I will plug in 20. Is this okay so far?
Okay, so I have a question when you divide by x.
This is the function. Oh, this is the function.
Yeah, yeah.
Oh, okay.
How did you get 75x to the power of negative 0.2?
Yes. So 75 x to 0.8 divided by x is 75. Copy the base, subtract the exponents.
Oh.
And 0.8 minus 1 is negative 0.2.
Okay.
If you have the time to review the last lesson, I had another example.
Yeah.
Okay.
I'll look back at the videos.
No, we haven't finished. So we only determined p of x, and we determined p of x over x. Now we have to differentiate it. When we're done, we have to plug in 20. So this problem has a lot of steps. So let's differentiate it now, because we haven't done that yet. So p of x over x prime. I bring down negative 0.2 and then subtract 1 from the power. So I have 75 times negative 0.2 times x to negative 0.2 minus 1, which is negative 1.2. Bring down negative 1 plus 900 times x to negative 2. If you want, you can say times the inner function prime, but that's 1. And now I have plus 18 times 0.3, because I bring the negative and there is also a negative, times x to negative 0.3 minus 1, negative 1.3. this is the function in which I will plug in 20. And that will be the rate at which the average profit function will change when 20 units are produced and sold. Okay? I highly recommend clean it up and then enter it in the graphing calculator and then plug in 20. Okay, so let's clean it up. So this is 150, so it's 15, so negative 15 x to negative 1.2 plus 900 x to negative 2. What is this? 60, is it 64, 6.4? Correct me if I'm wrong. 54. And 1 decimal. So one more time. Yes, 54. So this is the function in which I will replace x by 20. Not by hand, of course. I will put everything in the graphing calculator. I recommend, of course, it's up to you. I recommend this, which means enter it in the y equals so you can see it, make sure that it's correct and correctly entered. Okay, so enter it as negative 15 x to power negative 1.2 and then plus 900 times x, and the power is negative 2. You know I love parentheses. And plus 5.4 times x, and the power is negative 1.3. And now I plug in 20. So the rate of change is 1.95. So P of x over x prime when x is 20 is 1.95 dollars per unit. Any questions?
Wouldn't it be a negative or a minus 5.4?
Yeah, let me check. Let me check. So I have a negative 18, and when I bring down negative 0.3, that changes into positive. Because
See, I copied it wrong.
no, that's okay. I'll rather go back and check. Errors may occur at any moment. So it's negative 18, and when I bring down negative, maybe I copied it incorrectly from the book. Oh, no. It's the, I have to subtract. When I subtract the cost, I have to subtract both quantities. I cannot just distribute to the first one without distributing to the other one. I have to subtract the entire cost. From the revenue, I subtract the fixed cost, and I have to subtract the variable cost. Then I have to divide each and every term by x to get the simplified form, and then I'm ready to differentiate. And when I differentiate, I bring down a negative number, so that's why it's positive. Is that okay? Now, you will have a question in which you have to determine the derivative, maybe the equation of the tangent line, but you have to find the derivative using a simple example, but you have to find the derivative using the definition of the derivative function. Do we need to review that?